Good day, ladies and gents. All right, so today we're going to be talking about Unit 6. So these two are definitely on the Unit 6 hot topics. And then these two is actually, we did dilations in this unit, but it was on hot topics number 3. And then partitions actually moved to Unit 1. So there's partitions where I also suggested that this makes sense to me, but you might want to add another example to this. So this is just steps, but you might want to actually put numbers to go along with this, an actual number example. Okay, and then for dilations, here's dilations. It's in transformations, which is Unit 3. And then here's Unit 6, hot topics, which was handwritten. It gives you all these little examples. All right, so let's go ahead and get this done. So we're starting on page 17. All right, so page 17. All right, so on page 17, use the figure to complete this. All right, so a couple of things that we need to know is what equals what, right? So I can do a z where this angle equals this angle, right? And then I can do a backwards z where this angle equals this angle. So those are like the really easy ones, right? So if I reset this, it would probably make a lot more sense. So see that bottom triangle right there? That is single right there and a double right here. Well, then if I just copy paste it with the big one, so single and double, right? All right, so where is everything located? All right, between single and double is the F. Between the double and the nothing is the E. Between the nothing and the single is the D. All right, now do the same thing here. All right, between the single and doubles. Here's single, here's double, that's letter A. Single and nothing is C. Single and nothing is C. And then double and nothing is B. Double, nothing, B. All right, and this makes a lot more sense on where everything matches. All right, so A over F. So I did the big over the small, right? So we just have to keep up that pattern. So this is the big one, this is a small one, and we did this one over that one. So just keep that pattern. So big over small. So if I did the big one over the small one, it'd be what over the letter E. So E matches up with the letter B. So B would go right there. Simple as that. All right, on this one, all right, so we would just compare this. It's all about making proportions, right? So the easiest one is just 8 over 12 is equal to 6 over x, and then you would just cross product. So just equals, these two go together, 8 times x, and these two go together, 6 times 12. And it's your job to finish solving that. All right. Okay, on this one, it's the same idea. You might want to just put these in order. That's a good way to do it, or just match up stuff, right? So a couple different ways of how to do this. Well, it kind of just looks like it reflected and got smaller, right? So if I do, okay, so you just have to keep up the pattern, this over that, or whatever. So I'm gonna do that. This will be my top. This will be my bottom. So that's the top of the fraction, that's the bottom of the fraction. All right, so if I want to compare the x with this, right? So this has to be on the top, so it'd be 10 over x is equal to, now we just have to compare two other sides. So if I did 10 over x, that would match up with, just pick something else, and 6 would match up with a 5. So 6 over 5, and you would cross product. So these two go together, and these two go together, and it's your job to finish it off. So I would get 50 equals 6x. You would finish doing that. So 50 equals 6x. How do you get x by itself? You would divide by 6 on both sides. And then, and later on they're going to say, give it to the nearest hundredths. So 50 divided by 6, and we get 8.33333333 equals x, right? Now they said to the nearest hundredth. So to nearest hundredth, the question is, are we staying at 0.33 or are we going up to 3.4? And we would stay at 8.33 would be your final answer. All right, so 8.33 would be my final answer. I'll zoom out so you can see that a little better. And moving on to the next problem. Okay, so next problem here. Okay, so on this, okay, now to prove triangles are similar, prove triangles are similar, here are the steps. So first of all, do your givens, work off of your givens. You would try vertical, you would try reflexive, and then these are the three ways of how to prove the triangle is similar. And remember, corresponding sides are proportional, corresponding angles are congruent. You definitely need to memorize that. All right, so the three ways. So AA similarity, SAS similarity, and SSS similarity. Those are the only ways on how to prove that triangles are similar. That's it. And remember that corresponding angles are congruent and corresponding sides are proportional. That's the rules, right? Okay, so let's compare stuff. So let's see. How many sides do you see here? We only see two sides on one triangle, just looking at one triangle. So we're going to try this one right here. So the question is, does the middle angle equal each other? So let's see. When these two sides meet up, it is right here. So the question is, does this angle equal, let's look at these two sides. When they meet up, that makes that angle. Now, are these two angles equal, yes or no? In this case, yes. Why? Because they are vertical. Okay, so far we were able to prove that the angle in the center is equal. So it's called the included angle. All right, so now we just have to compare the sides. So we're going to do, now they said LMN. That's the first one. So this will be your top, and this will be your bottom of the fraction. The top of the fraction, the bottom of the fraction, because from left to right, top to bottom. All right, so put the numbers in order. So I have 6 and 9 are on top. And on the bottom, put the numbers in order. That'd be 4 and 6. The question is, are these proportional? Meaning, are the fractions equal, right? So just simplify. What can you take out of 6 and 4? I could take out a 2, and I would be left with 3 over 2. And what about this one? I could take out a 3, and I'd be left with 3 over 2. Now, are those two equal? Yes, it is. So those are proportional. Okay, now the question is, when I go L, M, N, that path, L, M, N, I did the nothing, then the 6. All right, so I did the nothing, and then on top was the 6. So I would do the nothing and the 6. That would match up with the nothing and the 4. So nothing and 4. So that'd be OPN. OPN. And what was the rule that we used? We used SAS similarity. So this worked. So the answer was A, yes. And these were the things that go along with it. If the answer was no, we would say either. So if the answer was no, but it's not, but if the answer was no, we would say corresponding angles are not congruent or corresponding sides were not proportional. What was broken? That's the question. Was it the angles that was broken or was it the sides that were broken? Okay, so I'll give you a start here. So the question is it AA similarity, SAS similarity, or SSS similarity? That's the question. So how many sides do you have on one triangle? And then figure out which one would you try to use. Then you would write the sides in order. You would see if the angles are the same, stuff like that. But in this case, there were no angles. So this is out and this is out. So it's probably just going to be this one. So put these in numeric order. So 6, 8, and 12. That would go on top because EFG is the first thing. So, and this would be on the bottom. And put those numeric order. And it said, so 10, 12, and 16. And then you would just see if those were equal to each other. So you would simplify each fraction, see if they work yes or no. And then if the answer is yes, it'd be SSS similarity. If the answer is no, what was broken? Was it the angles that were broken or was it the sides that were broken? All right, so that was number 17. All right, next. All right, number 18. Let's go to page 18. Page 18. So we're continuing our similarity. So for this one, we're going to be using heartbeat and boomerang, which I love ever so much. So heartbeat. So if the inside line is labeled with something, you're going to use heartbeat because the heart is inside. So it'd be this over this equals that over that. It's just making a proportion. This over this equals this over this. And over here for boomerang, if the inside is not labeled, you're going to use boomerang. So you always do the big hypotenuse first. Big hypotenuse first, right? So this over one of the sides, and then you backtrack. So this over this, but you don't make it all the way home. So it'd be C over A is equal to A over X. And please notice that these two are always the same. These two are always the same. And that was how you make the proportion. All right, so let's go ahead and get this done. Okay, so let's see. All right, so on this, we have a couple different ways on how to do this one problem. But let's see, if we're comparing the triangles, right? So let's see, they said that JGH, so JGH. So you see that triangle I'm focused on right here? I'm just redrawing it so I can help you focus here. So when I went JGH, I went like this, right? So this is the hypotenuse, and this is the short leg, and this is the long leg. So what path did we take? We went short leg, then hypotenuse. So we just need to keep that pattern. So short leg, and then the hypotenuse. That was the path that we took. All right, so pick another triangle. So we did the medium triangle. Now do the other triangle, which is a small one, right? Where this is J, F, and G. And we're just going to keep up that pattern. So we said short leg and then the hypotenuse. So here's the short leg, here's the hypotenuse. What were those letters? That'd be J, F, G. And then J, F, G. Okay, and then the biggest triangle, which is this entire shebang right here. What are the letters? H, and then F, and then G. So we want to go the path of the short leg, which is here, and the hypotenuse, which is here. So write down what those letters are. Okay, so write down that path. So boom, 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 and write those letters. Okay, now if you got these two backwards, it's no big deal. It doesn't really matter. Okay, over here. Okay, so on this one, so if I go B, B, C, so that right there, so B to C. Now that was the two legs, right? So I did a short leg and then I did a long leg, not the hypotenuse. I did short, then long. So short, then long. That was the path I went, short, long. So I need to continue that pattern. So I'm doing the middle, the center line right here. So that's going to be heartbeat, right? So boom. So this over this equals that over that. So that'd be the short leg and then the long leg. So that'd be C over D. And let's see if you can figure out this other one. So BA. So I went BA, right? So in that path, I did a short leg and then a hypotenuse. Did short and hypotenuse. So short, hypotenuse. So then A would have to be the short side. If that's the short side, what would be the hypotenuse if this is a short side? And you put down that letter. All right, number 3. Okay, so number 3. Is it heartbeat or boomerang? Okay, is the center line labeled? No. So this one's going to be boomerang. So for boomerang, you do the entire hypotenuse first. And then you do one on the side. So this side, there's nothing, so I'm going to go this way. This, and then you backtrack over this, over that. Okay, so what would be this entire distance right here? That entire distance, 9 and 16. So 9 plus 16, and you get 25. So this entire distance from here to here is 25. So it'd be 25 over. So all of this over this. And now backtrack. X over 16, but you don't make it all the way home. X over 16, and you would solve. Okay, and on this one, is it heartbeat or boomerang? Okay, the middle side, the center line, the inside is labeled, so you're going to do heartbeat. So for heartbeat, it'd be this over this equals that over that, just like a heart monitor, right? So it'd be 15 over X equals X over 10. And then you would cross product and solve, right, for both of those. And make sure that you're simplifying the radicals, right? Now, how do you simplify the radicals? Okay, now when we're simplifying the radicals, let's talk about this for a second. All right, so simplifying the radicals, if I said that I had 5 radical 180, okay, what's the biggest square you could take out of this? So 180, I can take out a 9 for definite, right? So if you divide by 9, you get left with 20. Now, can you take anything out of 20? I can take out a 4. Like, what's the biggest number? I can take out a 4, so that's 4 times 5. Now, what's the square root of 9? That's just the number 3. What's the square root of 4? That's just the number 2. And you're left with the square root of 5. And then you just make it pretty. So that's how you simplify radicals. And that will be your job. All right, so that was 18. Okay, so now let's go to page 19. We're going to be doing dilations now. All right, so we're on page 19. So something that might help you guys out is having graph paper just in case, just off to the side. So having an extra graph paper might be very beneficial to you guys. All right, so let's see. So we have this right here, the coordinates, boom, 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 and we want to do these transformations. So which one of these preserve all the angles and all that stuff? All right, so getting out this, what preserves everything? So the only thing that, so image is congruent, that's if it's one of these right here, but as soon as it does dilation, that's when you're not preserving stuff anymore, right? But they want to preserve the distance and the angle measure. So the distance. So basically, anything that doesn't have multiplication, because that's what dilation is, right? Dilation is you're multiplying by stuff. So not this. See how we have multiplication there? Not this. Not this. This is the only one. And what is that? That is actually a translation where you just slid it over. Translation where you just slide it over. And here is an example of that right here. So translation, you're just adding stuff, right? Just adding stuff, adding or subtracting. Okay, excellent. Okay, in this figure, the dilation, and we're centered at point A with a scale factor of this. Dilation centered at A. All right, so what's going on? All right, so if we think about this for a second, if we blow this up, right? If we blow this up, that means that we got either bigger or smaller, right? So the image of the rectangle has a dilation of this. So if we think of our SAV chart, SAV, so that's side, area, volume. So if my scale factor was 2 over 3, then my area would be 2 over 3 times 2 over 3, because you're in the second column. If your volume, that'd be 2 over 3 times 2 over 3 times 2 over 3, because you are in the third column. Now, can we make this prettier? That's 2 over 3, that's 4 over 9, and that is 8 over 27. Okay, so side would be the same thing for perimeter. So the perimeter would also still be 2 over 3. So now, would the perimeter be 3 over 2? Nope, so B is out. The area, would that be 2 over 3? No, that'd be 4 over 9. So this is out and this is out. So A is the only one that works. A is the only one that works. That keeps the SAV chart happy. Side, area, volume. Awesome. So you might want to put that on your hot topics if you don't already have it. Very important. Very easy to have. All right. Number 3. Under which transformation will the image not be congruent? Which is what we just talked about. So when will things not be congruent? When we say anything about dilation, now see, it'll blow up. It won't be the same shape anymore. So you should be able to answer that question. So that's up to you guys. All right, number 4. On this graph, we have these coordinates. What are the coordinates of B prime, C prime? Okay, so if it goes dilation around A and has this. All right, so this is the important thing. When you are centered, not at 0, 0. If your center is not at 0, 0, here are the steps. First of all, write out the coordinates. You would undo the center. Then you would dilate that, and then you would redo the center. That's simple. All right, so let's write these down. So B, C, where are they originally located? B is at 1, 2, 3, 4. So 4, comma, 1, 2, 3. And C is at 2, 1. Okay, so your first step is that's your original. Okay, you want to undo the center. Now, what was the center? The center was at A, which is at 1, 2, 3, comma, 1, 2, 3, 4. So what's the undo of that? That would be minus 3, minus 4. So you're going to take all of your x's, subtract 3. So 4 minus 3 is 1. 2 minus 3 is negative 1. All right, and then take all of your, take all the other ones. So all your y's and subtract 4. 3 minus 4 is negative 1. 1 minus 4 is negative 3. Okay, now we can dilate. And we're going to dilate by 2. So take all these coordinates that you just did. So column 1 turned into column 2. Column 2 is going to turn into column 3. That's the goal. So we're going to do 1 times 2. So 1 times 2 is 2. Negative 1 times 2 is negative 2. Negative 1 times 2 is negative 2. Negative 3 times 2 is negative 6. All right. And then finally, you reattach your center. So redo. We're going to add the 3 back on, and we're going to add the 4 back on. So 2 plus 3 is 5. Negative 2 plus 3 is 1. Negative 2 plus 4 is 2. Negative 6 plus 4 is negative 2. All right, and those are your coordinates right here. That right there is your answer. So where did B land up? B was at 5, 2. So that's gone and that's gone. And then your C was at 1, negative 2. So that's gone. So A was the only answer. And if you still weren't sure, you could just plot stuff and see if it worked. So that was another thing. You just have to make sure that it stays on the line. So let's do some examples of this. Okay, and then let's see. If I had plotted the first one, okay, if I did 1, 2, 3, 4, 5, and maybe doing this in pencil would be better. Wonder if I have a pencil. That way you can just keep erasing stuff and see what works. If only I had a pencil. Pencil, yay! Okay, so let's try stuff. So on this first one, we have 1, 2, 3, 4, 5, 1, 2. That's my B, and then 1, negative 2. That's my C. So the whole point of this is making sure that with my A, my A and my C's are all lined up on the line. Yes, so that checks out. So far so good. Now if I try this again, okay, 1, 2, 3, 4, 5, 6, positive 1, and 0, negative 1. Okay, so if I did that, this definitely doesn't work. See how my C is not in line? So that definitely, so I could totally toss out B because my A and my C's are not lined up. Okay, and then 5, 1, 2, 3, 4, 5, 0, and 1, negative 2. Okay, that doesn't work. So see how my B's are not lined up? So that doesn't work either. And then finally, the last one. So just seeing if things match up, right? So the last one, 1, 2, 3, 4, 5, 1, 2, and 1, 2, 3, 0. Yeah, that definitely doesn't match up too. Because I mean, my B's or my my center and my B's work. However, my center and my C's do not work. So that doesn't. So even if I was just graphing it, I just need to remember that these have to all be on the same line. My center and my what I blow up have to be all the same line. See how that? So here's my center, and it blows up. They're all on the same line. Yeah. Okay. Awesome. Okay. Number 5. The line whose equation is this is dilated with this scale factor. What is correct? Okay, now so this is a line, right? So a line. So I have no idea what, but I'm just going to draw something. This is not the line, but let's just say if I blew this up, around the origin. So if it got double its distance, so it went to here, double the distance it got to here. What do you notice about this line? It got further distance, right? Now, this is a line that continues on forever and ever and ever and ever, right? What do you notice about these? So that would mean that they are parallel, right? So let's see. The image of the line has the same slope, yep, but a different y-intercept, yep. The image of the line has the same y-intercept, no way. The image of the line has the same slope and the same y-intercept, nope, doesn't have the same y-intercept. The image of the line has a different slope, nope, they have the same slope. So the only one that worked was A. Sweet. All right, and page 20, last one. Page 20. All right, so on page 20, all right, so on page 20, given the points Q and T, so we're doing partitions, very important. So partitions. So looking at partitions, here are the basic steps. What you do is you make a right triangle, you find those two distances, you take the partition 2 and 3, you divide it by this magical number. That's your step 2. So let's just start there. Okay, so first of all, we're going to make a right triangle right here, right? Okay, so we're gonna go from your dot to your corner. 1, 2, 3, 4, 5, 6. That's 6. And from the dot to the corner. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then we have a ratio of 4. So our ratio is a 4. So we're going to take the 6 we're divide by 4 and the 8 divided by 4. We get 2, and 6 divided by 4, we get 1.5. Awesome. All right, so don't overthink it. All right, so now take your coordinates. So if I start at Q, is it Q? Yep. So Q, so leaving some space at the top, we have Q, which is at -3, +1, and we're going to go 4 hops. So 1, 2, 3, and the 4th hop would be T. So we went 4 hops. 1, 2, 3, 4, and the 4th hop is T. We are going, and T is going to be at +5. 1, 2, 3, 4, 5, 6. Let's try again. 1, 2, 3, 4, 5, 6, 7. 7. So 5, 7. All right. So now what we're going to do is, so this way, we're going to add or subtract the 2. And then this way, we're going to add or subtract the 1.5. Okay, now going from -3 to 5, are you going to be adding numbers or subtracting numbers? Starting from a negative, going to a positive, we're going to be adding money, right? So add 2. Going from a 1 to a 7, we're going to be adding. Okay, so now we're going to take our calculator. So we're starting at -3. We're going to add 2. So +2, we get -1. +2, we get 1. +2, we get 3. And +2 again, you better land at 5. If you don't land on 5, if you don't land on this number, two things that could have happened. One, you subtracted instead of added, or vice versa, or you have these two numbers backwards. So always make sure you land on that number. Okay, let's start on this side. So we're starting at 1, and we're going to be adding 1.5. We get 2.5. Add 1.5, you get 4. Add 1.5, you get 5.5. Add 1.5 again, and you get 7. And I check mark it, and it works. Okay, so basically what's happening is you took this right here, and you broke it up into four sticks. You had one big log, and you broke it up into 4 sticks. Now, what were those sticks? You were at, and I'm just showing you what it is. You don't have to do this part, but we're at -1, 2.5. Yep, that's still on the line. And +1, +4. Yep, that's on the line. And then we have 3, +5.5. Yep, everything matched up. And do those sticks look exactly the same? Yes, and you have 1, 2, 3, 4 pieces of sticks. Okay, then they're saying, here's the important part, the partition is Q to T. So starting at Q and going towards T, you're going to go 1 hop, and you should have 3 hops left over. That's what it means. So 1 hop with 3 left over. 1, 2, 3. 3 left over. So this is where you landed, and that is your final answer. And they might want you to put that in fraction form. They did want that in fraction form, so let's write that. So that'd be parentheses, that's -1, comma, and how do you write that in a fraction? Well, that is 2.5, right? So that's uh, 2.5 over 10, and then you would just simplify, or you would just make it into 5 halves. So that is 5 halves. Boom. Okay, and then you just rinse and repeat for the rest of it. All right, so everything is pretty much simple. Just have a good and wonderful day.